Assalamu alaikum. Okay, so as I've told you earlier that in the upcoming labs we will be studying the digital logic design portion of the electronics, in which we will start with the logic gates and we will make the combinational sequential circuits, and then we will move towards the adders and subtractors. Well, starting with the gates, gates circuits like AND or NOR, NOR, XOR, XNOR. These are available, or these gates are available in the form of an IC. Every gate has its own IC. See, IC like this. It can be 8 pin or it can be 14 pin. But this is, for example, a gate IC. I'm not telling you now that which gate does it represent. We will find out a bit later. uh, First, let's move towards the construction, or you can say a structure. If you see at the top of the IC, you will find a notch. What is the significance of this notch? It represents that on the left side of it, the pin numbers starts. For example, if the notch is here, the pin number 1 is this one is pin number 1, then 2, 3, 4 from the left side, up till 7 here, and then 8 from here, from this side. This is 8, then 9, 10, 11, 12, 13, 14. See, so this notch represents that the numbering starts from the left side of it. Now, to uh, to use this IC, first you need to power up the IC. So there are two pins for powering up the IC, that is pin number 7 and pin number 14. Pin number 7 is this is the pin number 7, and this is the pin number, this is the pin number 14. These two pins are to power up the IC. This pin right here, pin number 14, is the VCC pin. You will provide positive 5 volts here, and this plus 5, you can say, and the negative will be, or the ground will be provided at 7 pin number 7. So these two pins are here to you can say power up the IC, to use its gates basically. Now you know that every gate has three terminal, two for the input and one for the output, like and gate has two inputs and one output. Similarly, or similarly, not, except not has one input and one output. Not simply inverts the input. So when you give 1, it will provide 0 as output. So here is an IC, and if it is IC other than NOT gate, then you know that we need three terminals to represent one gate. So except pin number 7 and pin number 14, that is for powering up the IC, there are 12 pins left. See, there are total 1, 2, 3, 4, 5, 6, 7, and 7, 14 pins. 2 are for the for powering up, and the remaining the left are which are left are 12. Divide 12 by 3 equals to 4. It means the IC contains 4 gates of same type, whether it is an OR IC or AND IC, but it contains 4 gates. We will discuss about it, how they are arranged in the internal circuitry of the circuit in the class, but for now you should know that it contains 4 gates of same type, uh, whichever this number represents. Well, let's check it out, which uh, gate it is. Okay, so now we'll check that which type of gate is represented by this IC, that is 74LS266. You have a quick search question, that is, what does the word LS means in the IC? The number stands 74LS266, and what is the difference between 74HC266? See, This is the question that you will add in the manual at the end, and plus the question that I will give in the class. Well, let's see. I have connected the positive to the 14 pin, negative to the 7 pin. So basically I have provided 5 volts to power up the IC. Okay, as I've said, there are 4 gates available in the gate IC. First gate is between first 3 pin 1, 2 and 3, where first 2 are inputs and third one is the output. So basically you will get the output from the third wire. Now to third terminal. Now to check the output, you need basically a LED that will glow if the output of 1 appears, and 1 means basically 5 volts or above 3.5 for CMOS, and for TTL above 1.5, as I have already told you in the first class. Okay, so 1, 2, these two are inputs and the third one is output. I will give input to these 2 pins, either 1 or 0, and output will be and we will get the output from the third terminal. Similarly, next 3 pins too are in the same order. First 2 pins as the input and third one for the output. 7th one is ground. Again, from this side, I guess it's again the same. These 2 for input and this is for output. Well, I need to check it a bit. Well, this is confirmed from this side. यहाँ पे भी वैसे ही होगा कि ज़रूरी नहीं है, मतलब हो सकता है ये 2 इनपुट हो या आउटपुट हो, ये 2 इनपुट हो या आउटपुट हो, ठीक है, लेकिन होगा इसी तरह, सही है, तो वो हम चेक कर लेंगे बाद. Here I am using this gate, सही. So again I am repeating it, 2 gates here, 2 gates here, and I am using the first gate. I have used a pull up resistor in the output. A pull up resistor means you basically connect the pin that you want on which you want a pull up resistor to the 5 volt pin or the high pin. So you basically connect a resistor between that pin and the high input, that is 5 in this case. This resistor is called pull up resistor. Basically you are pulling this pin to a higher voltage. We do this when we are unable to get the required output, required high output on the output terminal. For example, if I remove this resistors and give the input to the input terminal from these 2 wires. See, these 2 wires are for the input. Again, this whole string, this whole series carries the negative voltage from the coming from the DC power supply, and I'm using these sources, this source. See, and it is of 5 volt already. We do not need to set it to 5. So, and this upper series is the positive. So whenever I need a positive or high, I will simply pick it from this series, and whenever I need a ground, I will pick it from this series. Okay. So let's check what will be the output at 0 0. So basically I need to connect both inputs on the 0 terminal, ground terminal. So connecting it, first one to the ground and similarly second one again to the ground. It shows no output. See, but again at 1, first pin at 1 and second pin at 0, again you are saying no output. Both pin on 1, again you are saying no output. So it means that there might be an error in the circuit. This error is that you are not getting high enough output to the output terminal that is able to drive the LED. So for this you connect a pull up resistor. Pull up resistor is the one that is connected between the required pin and the high terminal, that is in this case 5. A pull down resistor is the one likewise that is connected from the required pin to ground terminal. Okay, I will discuss about it in the class. What is the difference between the pull up and pull down, and bulky take it as a quick search too. What is the difference between plus what is the difference between pull up and pull down resistor? Okay, now again let's give it the input. Now both at 0 0. Let's see what will happen. This one is 0 and the other one 2. No, both at 1, sorry. See, the upper series was for 1. Both are connected with 1. Am I getting the output? Yes, I am. See, the LED is glowing. Okay, now let's check at 1 0. This one at C. Now it's off. It's not glowing. So basically what happened here that it gave 1 at 0 0 and 0 at 1 0. Now let's see what will happen at 1 1. Sorry, 0 0. Yes, at both 0 0 it gave 1. At both 1 1, this one is 1 and this one 2 at 1, it also gave 1. And at 1 0, this one is at 1 and the other one is 0, again 0. This one is at 1 and this one at 0, again 0. So you should know which type of gate is it representing. You will write it in the manual. Okay, see you in the class. Okay, one last thing. As you are saying that I have not connected the LED directly to the output. I have connected the LED in series with the resistor and then with the output. This thing is done to save the LED from damages from the over voltages. As you know that these LEDs operate between 1.5 to hardly 2.5 volts. If more voltages are given above 2.5, then the LED gets damaged. So you need a resistor in series with it so as to protect the LED from the damages of over voltage. As you know that the output is of 5 volts, and if I connect the LED directly to the output, it will destroy it. Secondly, if you see the construction of LED, let me show you. Okay, it's not visible, but if you check the LED internally, or you can say visualize it, you will find that the internally there are, you can say, two aluminium or two metal strips. First one is a bit thinner and second one is a bit thicker. The thinner one is for the positive and the thicker one is for the negative. So the output should be connected with the thinner one, that is the positive. So the this one is positive, and then the negative is connected with the negative pin through a resistor to protect the LED.